All right, let's do an overview of chapter 4 in 5 minutes. So here's what we're looking at. We're hoping to take a population and get a sample from it so we can make a best guess about what we think the data should be or what we think the information from the population should be. Notice this sample is not a good representation because there's no green and yellow people. So I always want to make sure my sample I take represents all the characteristics in my population. I'm also hoping that when I take results, they're quote unquote accurate, which in this case would mean low bias and low variability. So however I've sampled, my results generally line up where they should line up, the true value being the true value from the population, everybody, and the little sample results I get hopefully line up with that. Low variability is we've got everybody together. All of our data is clumped so I can make a good prediction. Ultimately, I'm hoping to take a small sample and hope that that allows me to make a prediction or inference based on the population, so I don't have to take everyone. So these are not great in stats, these other three. This is what we're shooting for when we're accurate, low variability, and low bias. There's multiple ways to sample. Stratified and cluster are two that get confused a lot. Stratified sampling, all groups have the same characteristic in common. So in this case, all of my groups have the same color. Cluster is your groups are mini representations of the population. So they're already set up to show you all of the colors. So what do? We want to label our people, our test subjects, or things we're picking with numbers, generate random numbers, and then do a selection process. You have 4 options for a selection process. Simple random is you just pick from everyone based on the numbers that come up. Stratified is you have to split your population into groups first based on a characteristic. So here I've organized everyone by color, and I've randomly selected from each of the groups to make my sample. Cluster sampling, you already have groups preset. So again, you're just going to randomly take a group and take everyone in that group and combine all of those to make your sample. Systematic, we're going to go every so many things or people. Just randomly select your starting point. 2 things not to do is convenience and voluntary sampling. So convenience is easy, but notice this doesn't represent your population. So whatever guess you're going to make based on the sample of the whole population is going to be biased because you're not getting everyone. Voluntary response is taking volunteers. Only people that are passionate generally will tell you how they feel, and therefore your results will be biased. In terms of experimentation, we are assigning a treatment to groups. That is a big difference here. So we also want to make a guess about the population, but we're going to do it in a slightly different way. So instead of just observing based on things we collect, we're now going to make people do things. So random assignment is the biggest key when you're doing an experiment or some sort of experimental design. So in this case, I would take all of my population all of my sample that I'm looking at, split that into 2 groups, assign each group a treatment, and then compare results at the end. This is a completely randomized design. In terms of a block, you have to add a step. So the biggest step to add is just splitting your population down by some sort of characteristic. That characteristic is something you think that will affect the results. So doing a blocked experiment can lower the variability if you think there's something that's going to mess up the results you're seeing at the end or influence them somehow. So split everybody up, then run your experiment on each group. Matched pairs, you have to pair people first. So perhaps there's a characteristic you'd like to test or you'd like to fairly distribute among your group. So here I'm pairing people up, and then based on the pairs, each pair, one will get a treatment and one will get the control. Now, things that mess up experiments, just like bias in surveys, are what we call lurking variables or variables that hang out. So generally I take the track of some sort of explanatory variables, in this case a method, hopefully indicates a response that should happen. But sometimes there's a variable that will come into play that might mess up what we're seeing here. So instead of me thinking my method is working, it could be because of this variable that I haven't controlled for, that might be influencing my response. So what do? When we're doing anything in chapter 4, we're taking a population, taking a sample, and making an educated guess. So if you're doing just a random sampling with one of the methods, you can say there's a correlation there, and you can make an inference about the group that you picked from. If you're doing random assignment, that means you can do cause and effect. So if you've done an experiment, you can say cause and effect if you've done random assignment. If you do random sampling with an assignment, you can say there's a correlation, you can make an inference about your population, and you can conclude cause and effect.